My name is Eric Paler. I'm a professor of classical archaeology at the University of Massachusetts Amherst. And on today, the day of archaeology, I want to talk about a couple of things that are going on here at UMass. It's the first time in 17 years that I'm not in Pompeii, where I do most of my field work on Roman architecture and the experimentation with digital methods and digital tools in order to do that work a little bit better. I guess in earnest, the day of archaeology really started for me on one of my projects, the Pompeii Quadriporticus project. And I'll be showing a few things behind me so you can see some visuals of this. Working on images late last night to get the inventory of the different faces of walls that we have photographed and finding out which ones we have and which ones we're missing. We're building a Flickr site, and so that is going to be one part of our repository, a good way to share the information, but also a good way to kind of organize it. So that's going on now, and at the same time, we're building a simple Google Doc to track the information that's out there. This is important to do right now because there are people, unlike me, who are actually in the field. Two people from the Quadriporticus project, our field director, Ben Crowther, a PhD student at Texas, is in the field along with Juliana Van Rogen, who is a UMass undergraduate student in her final year. Both of them are working for the Quadriporticus project and also for a sister project, the Pompeii Archaeological Research Project, Porta Stabio, directed by Stephen Ellis, for which I also work, and I'll talk about that in just a moment. Not only are they documenting the walls by taking photographs of them and getting ready to do other kinds of work with that, but they're also getting ready to do a little bit of photogrammetric documentation as well. So we did laser scanning in the quad, and now we're trying to clean up a number of places that have escaped our laser scanner. And you can see one of the examples here we have loaded on our website. This is one of the photogrammetric reconstructions of a relatively important section of our building. And you can see the nice way in which this renders a three-dimensional environment that is much richer and much more like what it's like to actually be there in the field. So Ben and Juliana will be capturing that imagery today during the Day of Archaeology. One of the other things that I'm down here doing today is actually taking a photograph of this kind of clunky machine here. It's another thing to thank Ben Crowther for. It's a portable portable do-it-yourself DIY spectrometer from Public Labs. We experimented a good bit last year with this to relatively mixed results. And so I'm taking a photograph of it now so that you can read those mixed results in our forthcoming publication on the 2013 field season. It's the last image that we actually need for our publication to the FOSTI, which we'll be submitting probably on Monday morning. You can check out more of our publications if you care to. They're on the website. The other reason that I have other thing I have down here is a journal from 2009 produced by the surveyor for the Pompeii Archaeological Research Project, and here's the website for PARPS, Sid Evans. Right now, a number of people are working on the spatial and geospatial data that we have for PARPS, and one of the things that we need to do is to track down individual pieces of that. The physical object of the book is not in place right now, so we need to scan that and get it over. So that will be part of my Day of Archaeology today as well, is scanning this book and sending it over to Pompeii so that Greg Tucker, who's from the University of Michigan, who works on PARPS, will be able to deal with some of that information. As I mentioned, both Ben and Juliana are working with PARPS, along with Alex Marco from Columbia, who have a team together to work on the architecture of the two city blocks that PARPS is working on, and I'll show you them here. They are 8-7, Region 8, Insula 7 here, and Region 1, Insula 1. And putting together the story of these two architectures of these enigmatic and interesting city blocks. I don't want to get into much with with what PARPS is doing. Perhaps Stephen will be talking on his own Day of Archaeology post or blog today, so I won't go over that. But other than that, to say that a good part of my job for today in Day of Archaeology is to help assist Ben, Juliana, Alex, and Greg to do the work that they need to do while in the field while still here. So I guess my title is Head of Architectural Studies, so as head, I'm trying to maintain their workflow and the flow of information, the data that they need. Today is also a very busy day for a third project that I'm working on. So yeah, I saved a lot of stuff for Day of Archaeology, and you'll see a few more things in a little bit. The third one is called the Pompeii Bibliography and Mapping Project. And this is a massive digital humanities project generously funded by the National Endowment for Humanities Digital Startup Grant and by the American Council of Learned Societies Digital Innovation Fellowship. And I thank both of those groups for their very generous support in this project. What the project is relatively straightforward. It's the marrying of an online GIS, which you can see here, with an online bibliography. This map is just going live, and one of the things I'm doing today is meeting with two groups. One is the group that's going to be helping out with this particular part of the map, and I'll try to zoom in a little bit here to show you that as it renders. Alexander Stepanov, who is a senior GIS architect for the campus here at UMass, is the main GIS person working on this project. And he and I have discovered, to our chagrin, that there are, as you can see, some holes in the data, but more importantly, there are places where the data doesn't overlap perfectly with the satellite data. And we have a number of reasons. You can check out the blog for the PBMP as to why that is the case. But what we're going to do, and Sasha has shown me how this is going to work, we're going to gently nudge today some of this data over into its alignment. I wouldn't say precise, and I wouldn't say accurate alignment. I would just simply say closer alignment to the imagery that we currently are receiving from Google and Bing to get the spatial data, the polygons and polylines, the points, to actually line up better. And so what you might be seeing in the image behind me is these red points, which are the actual points, as close as we can imagine them, on the digital image. And then the green points are those points that are on our layers. Sasha is going to use an algorithm script to try to position them as closely as possible to each dot, finding that happy medium between them without actually snapping one to any particular one. That should begin to rubber sheet our spatial data into place. The second meeting I have for today is with two excellent digital librarians at UMass in the Du Bois Library, Aaron Rubenstein and Ron Peterson, who've been really great in helping out to get what is ostensibly a 18,000 record database of citations about Pompeii, and to get that into digital form so we can go into places like Zotero. So we have a Zotero site available now. It is in poor shape, but that's okay. It's available for beginning to work with. And then we're moving that to have a mirrored site in Omeka as well. What we're going to talk about today on this work is two things. One is how to better import the data into Zotero and then move it across to Omeka. The reason for this process is that Omeka will import from Zotero, and Zotero will import from a number of bibliographic formats. Some of those formats Aaron has scripted to read from our spreadsheet. So spreadsheet to perhaps BibTeX or RIS into Zotero, Zotero into Omeka, and each of those stages there's a possibility of error, and we've discovered some of those. Perhaps the biggest error and thing that we need to overcome right now is the characters that we had encoded in our spreadsheets, as they go into the web, they lose some of that encoding in UTM, and they actually lose their accent marks. So you can see behind me a number of these little question marks. These are all places where our data is not actually doing what we want it to do. The final thing I want to talk to you about today, actually, is two tools I've gotten to use over the summer, and one I've been saving to put together. One, you've probably all heard of and seen before. Thanks to Joe Evans at the University of South Florida, I have Google Glass. And as embarrassing as it is sometimes to wear it, I'm going to do so today. And I'm going to, as perhaps silly as it makes me look, okay Glass. Oops. I'm going to record this through Glass. Okay Glass. Record a video. I'm going to record this through Glass in order to get this kind of first-person perspective as well, and also to admit how silly I look with these on. But that's okay. It's all part of education and science. And the other thing we're going to look at today is this pretty box that just showed up, the structure sensor. This is an interesting device to capture three-dimensional information and to make rapidly models of that information. Let me just show you two things about Google Glass that I'm interested in. We were able to do a couple things this summer with Glass. One was basically to take videos. That's the main thing I used it for so far. I'm just getting started with it, but it has a lot of potential. I was able to visit the island of Delos this summer, and on Delos there is a major building called the so-called Agora of the Italians that's been much studied, much argued about. It's a very good parallel in terms of its architectural form and perhaps some of its functions to the Quadraporticus at Pompeii, and obviously an object that I'm very interested in. So Glass was great because it allowed me to not only experience the building, but not have to take my hands off the world, not have to hold up a screen in order to document the building. And in fact, I documented the entire trip, almost the entire trip, so I have about 45 minutes of video, of which about 15 belong to the Agora of the Italians. And so when I come back and do comparative work with Stephen, who's the co-director on the, Stephen Ellis, who's the co-director on the PQP, we'll have a rich record that we can orient ourselves to the map and see quite clearly what it is that individuals might be arguing for or against as we learn more about the Agora. Another project that took me to Greece is also one that I work on with Stephen Ellis. It's the East Isthmia Research Project. And we took videos of with Glass here as well, largely to document the state of the site, to get some sense so that we could talk to other people about what the site looks like, to get some idea for ourselves of the state of affairs in the 21st century, as we're doing a legacy project there. And so for this particular example, it's really just kind of documentary. There is even greater documentary value, I think, with Glass that came from sitting in the library of Hill House at Corinth, the excavation house, and having conversations with Stephen Ellis and the two other people on the project, Allison Emerson and Karen Lawrence, who have experience with working with the methods that we had devised, more experience than I had in terms of trying to devise them. And so we used Glass to actually document our conversations that were going to then be used as documentation of our method. So what that means is that Glass is becoming a form of raw material production in the process of writing, in the process of thinking through what happened on an archaeological project, in much the way that I think we'd hope this would be done, even though most of those conversations that happen in the field don't happen in a way that you probably record. You probably don't produce them in the way that you expect with a video camera, but it was really useful I think, to capture all that. So the other thing that I want to show you then is the structure sensor. And this is a new device new device, but not a new technology at all. If you've heard of the Microsoft Kinect, if you've played certain video games, you're familiar with this technology, an infrared laser projector attached to a screen that helps find out where in space you are. I've actually left my iPad over here, so I'm going to go get it. Right over here. And I'll take out of the box here structure sensor. All right, structure. What you see coming out of the box is not how it's packaged. You get a nice cord. You get the sensor itself, which you screw onto this bracket, and then a cable that you use to attach and connect to your iPad. So I'll just move these things out of the way over here. Oops. These items out of the way. So, as with any live demo of something, it rarely works right. So we may have to pause our video here to get at that. The structure sensor mounts sidelong onto the picture side, so you want to find the picture here, find the hole, and these things then attach thusly over the top, and then clipping securely into place like this. You can attach the cable here, and then connect it to the iPad, which you see there. And then you download the app from the App Store, like this. So once you turn it on, there are 3 modes that you can use it in. This is the IR mode. This is basically just capturing. So I'll hold this up and send it out. If you push on this little guy here, boom, it turns on the infrared. And this is pretty cool because you can see that this is actually a night sensor. So let me turn off the light here in the lab. And you can see now that the light from the ambient light in the room and from the IR is now being recorded on this. So that's pretty cool. You lose your light for some reason, you can use your iPad. I don't know, that's probably not going to be the best use. The 2 other uses, so the IR is used then to range depth. So here you can see where the circle is located is showing us where the point is being recorded. And you can also see, okay, I have an email. You can also see then that the distance is measured in color gradients. So red is hot, blue is cold. It is in fact not. And so it will move to back wall almost 5.5 meters close to us here right in front. Very, very hot, 30 centimeters away. And then you can use the color to get the same thing. So you're getting the video feed through, but also then the color. I brought a Kylix reproduction from a purchase in Greece from years ago to try to demo this. One of the things that we're not seeing right now, and this is always the problem with these live demos, is there's a 4th choice called link, quick link. And this, when you have Scanit on, Scanit here, running on your computer, and that computer is connected to the same internet as your iPad, they should be able to talk to each other. I'm probably just not on the same one. Let's see. I seem to be on the same one. Okay. Great. What I'll do is I'll just turn it off and reconnect. Okay. Now hopefully, structure sensor likes to find it. Does not. What I did last time was I gave this a hard restart. I'll try that now. And see if it comes back. I'll probably cut this out of the video. But this is the normal thing that happens when you try to do a live demo. All right, let's bring this back up. back to me, iPad. Thank you. All right. I'm not sure what the procedure is on setting this down. I haven't yet understood how it's meant to be maintained, so it's all pretty new. So while we're doing that, you can see on the screen here, maybe behind me as well, that you want to select the kind of object you're going to model. So here I'm trying to select object. Gone to let's see, got prepare object. Great, it must be a small thing. Start that. Then goes to record, and great. Let's see. All right, we're online. We're connected. Structure. Quick link is not enabled. While we wait, I'll tell you that Structure IO has a great website that helps you get started. Tells you how to put it all together, and then on the second page, tells you basically how to get started with this kind of work. How to start making your first model. So you can see that here. I might have to do this on a restart. All right, let's try that. So hang tight, Internet. So let's give this another try. Looks like we're online. Thinks we're online. It's trying to think like it's online. And structure sensor. Let's get you restarted. Oh. Well, Google Glass, are you recording my sense of frustration? Probably. Okay, last chance. Uplink. Oh well. Well, this is the structure sensor. Apparently, in this kind of a network environment, there isn't a shareable, apparently, Wi-Fi connection. So it's having trouble getting things done and making that uplink connection. That's certainly going to be a problem. But let me show you via their web page what can be done. So as you can see, what's going to happen here is that once you've got the uplink set, you point the device at the image you want, and you'll see it. You'll see it registering through the depth and color. So it'll look like something like this. So I could go over here to our Kylix, and I can kind of, what I'll do is I'll paint it like this, very carefully, very slowly, getting underneath of it, something like this, around. I've already discovered that you're not to move pretty slowly and smoothly for the device to work. So it's going to look something like that. I was able to get this to work in my home office. I'm assuming that the reason that worked is because that's a single emitting network rather than the multiple networks that might be emitting. So it's going to look something like that. So that's what that process would be like. So that would finish. When you're done, you can then process it into Scanect software. It'll allow you to do a number of kind of cool things with it, including getting ready for some AR visualizations. Now, why do we want to do this? Why am I talking about this on Day of Archaeology? What would be the point of this? The point of it, to me, is the rapidity. It's the speed at which this device captures spatial information. What would we do with that? Well, on the one hand, certainly if you have an object and you'd like someone to take a look at it, one of the things you can do is produce quite quickly a fairly detailed examination of that object, model it in 3D, and then share it across the web so that that other person can then manipulate it in those 3 dimensions in a virtual version of holding it in your hands. That could be one great use for this. The other thing that I tend to think of is the rapid capturing of objects during very fast, very rapid kinds of archaeological research. So I take, for example, visiting multiple cities in search of different kinds of information. For myself, I study Roman traffic, and there are a number of curbstones throughout the Roman world that show which direction a cart was actually going. For me, being able to very quickly capture in full 3 dimensions that object in a matter of minutes would be a great opportunity to then bring those that information back. So last year I was in Tunisia, I was in Algeria, and bringing back from Timgad the information to Pompeii putting that together with a model of the objects from Pompeii and seeing how closely they resemble each other, that would be quite interesting to do. It would also be really interesting and useful to help people understand why the object can be interpreted the way that they can, or at least the way that I say they can. So putting those on the web will be a great help as well. And then you can just think about the speed at which certain types of salvage archaeologies, or quick kinds, very rapid kinds of archaeologies, how they occur and how this can add a rough and ready, not perfect, but still in many cases in some salvage operations, you don't even have time to plan. A photograph is all that you have, and if this can add a three-dimensional rendering, including capturing space like this, capturing architecture, and working in tandem with photogrammetry, laser scan, other types of high expense and high time, high expertise kinds of activities, then the structure sensor seems like it has a role to play, at least as a prototype, at least as a first step, and no doubt in the next 5 to 10 years we'll be seeing this as a standard piece of the archaeological toolkit. So despite all the delays and the troubles, the fact I couldn't actually show you how it works, that's fine. But this is the kinds of things I'm trying to do on my day of archaeology, even though I'm 3,500 miles away from the archaeology I'm supposed to be doing, or I love doing. Nonetheless, great things can be done in archaeology on the day of archaeology when you're not actually standing with your back against the sun and your trowel against the dirt. Hope everyone out there is having a good day of archaeology too. Cheers.